everybody, welcome back. We're going to do assignment 7 now. Assignment 7. Alright. This is where we started working on the median lines. And here we go. Okay, so number 1 on assignment 7. We've got two triangles. I tell you that these sides are equal and these two angles are equal. I let you know this. I tell you that this side is 10, which means all sides are 10 because I'm telling you that all these sides are equal. I tell you that this side is 15x minus 20. Now this is going to be side angle side. And I'm going to just set the 10 equal to 15x minus 20. Add my 20. Add my 20. 15x equals 30. X equals 2. Alright? That's all I want to know for that part of the problem. Number 2. Number 2, I have an equilateral triangle. Remember, an equilateral triangle, all the sides are the same. I tell you that this side is equal to 20. I tell you that this side is equal to 3x plus 2. And that this side is equal to 4y minus 4. So all the sides are going to be 20. What I want you to tell me is the value of y and separately the value of x. So it's going to be set up as 20 equals 3x plus 2. Subtract my 2. 18 equal to 3x. Divide by 3. X is equal to 6. So I'll put x is equal to 6 up here. So this is just a regular variable problem. Alright, so since this is 20, this is also 20. So I said that my problem is 20 equals 4y minus 4. I add 4 to both sides. So I have 24 is equal to 4y. Divide by 4. Y is equal to 6. Because 24 divided by 4 is 6. So now I have x is equal to 6. Y is equal to 6. Just conveniently worked out that way. I can't read very well. Okay. And that's number 2. Because I just wanted x and y. So that was a side, side, side triangle. Alright, number 3. I've got my big triangle. And I'm going to cut it. Now it's not in half. But I'm making a parallel line with the base. So here's the base. These are parallel lines. Alright, I'm going to say that this section, because remember, these are vertexes. Anywhere where two segments join, which means this is a segment here as well. So just like we did on number lines, right? We can just assume that's a segment, and we can assume this is a segment. Alright, so I've got 3 and 2, x and 1. Now remember, these aren't equal because I'm not telling you that these two angles are equal or these two sides are equal. I'm just telling you that these are two parallel lines. So an idea, a way to think about it is, remember we had our two parallel lines cut by transversals. So this one's going this way and this one's going this way. This one's going this way. This one's going this way. Okay, so these are two completely separate transversal lines on our parallel lines. So that's a way to remember why these aren't equal, because they're not equal. But they're proportional. I'll erase all this extra stuff. Okay, so what I'm going to do is, imagine this is one big triangle right here, and then a little triangle. So I can draw an extra triangle over here just so I can see it. Okay, so it's like I've taken a little piece and copied it and put it over here. Alright, so it's always going to be little triangle over big. And the way that we do this is we look at the little triangle, so we don't even have to look at this picture because I made a duplicate. And it's going to be 3 over the big triangle, which means I take out this right here and I add because I want this whole side. And this whole side is 3 plus 2, which means I'm going to put 3 plus 2 right here. I'm going to set these equal to each other because it's still proportional. My little x is x. My whole side is x plus 1. Okay? So I've got my whole side here is whatever value x is plus 1. So now I cross multiply. Remember, cross multiply going across like so. So now I'm going to take this over and I'll multiply x plus 1. I'll get rid of that and then I'll multiply over here. Now 3 plus 2 is 5, but I'm going to go ahead and write it out just so we see it all. Like so. Alright. So now I'm going to have 3, because I'll distribute the 3 and I'll distribute the x. So I have 3x plus 3 is equal to 5x. Because remember, 3 plus 2 is 5. So I just went ahead and made that 5x. So now I'm going to subtract the 3. So now this is just a regular problem. Subtract the 3x. Now I have 3 equals 2x. X is equal to 3 halves. That was a really bad x. Sometimes it's just really bad. Okay? So I cross multiplied, and it was originally set up with the little triangle information over the big triangle information because it's proportional. Alright, so the answer for number 3 is 3 over 2, or 3 halves. Next up, number 4. So I'm going to go ahead and put it over here to kind of get it out of the way. So these are two parallel lines. So I've got 7 and 4, and 3 and x. Remember, it's like these are all little tiny segments. And it's going to be little triangle over big triangle. So the little number right here, 7 over 7 plus 4. 7 plus 4 is equal to the little triangle, 3, over the whole side, which is 3 plus the value of x. Again, I'll cross multiply. And really, you do this with both sides. Alright, so now I'll have 7 times 3x, 3 plus x. You can cross that out. And then this is 11, so I'll have 3 times 11. Cross that out. So now I'll have 7, and I'll distribute it over. So now I've got 21, because 7 times 3 is 21, plus 7x is equal to 33. Because 3 times 11 is 33. I do my math. I subtract 21 from both sides. Now I have 7x is equal to 12. Divide by 7. X is equal to 12 over 7. Or if we break that down, that'll be 1 and 5/7. Alright, but as long as you can get through this stuff, this is what I'm worried about. I want you to practice all of this. I want you to practice the setup. Little triangle information over the whole triangle information. Not just the bottom, but the entire thing. Okay, so number 5. Number 5 is x and 1, 8 and 2. Remember, it's going to be little over big. So my little triangle information is x over x plus 1. This whole side is equal to 8 over 8 plus 2. The whole side. So I do my cross multiply with my handy dandy red marker. There we go. And then we go like this. So now I'll multiply the x. So this is 8 plus 2, which is 10. So I'll multiply this by 10, so that's gone. And then this by x plus 1. You can also write this as 10x equals 8 times x plus 1. Distribute. 10x is equal to 8x plus 8. Subtract my 8x from both sides. These cancel out. Now I have 2x is equal to 8. Divide by 2. X is equal to 4. Alright? We are moving right along. Next step. Oh, that's the last of these ones. Next step. We're working with the Pythagorean theorem. So remember, we've got a 90-degree angle triangle. There's my 90. And my formula is going to be c squared equals a squared plus b squared. The c is also called hypotenuse. Okay, so remember that. So the hypotenuse is always this long leg here. So that's c. I like to say that a is the altitude or height, and b is the base. So I gave you different numbers for the equation. So number 6, I tell you that a is equal to 3, b is equal to 4, and find c or h. Alright, so now what I do is I put it into both my equations. So I have c squared is equal to b squared, which is 4 squared, plus a squared. Now I have c squared is equal to 16 plus 9. C squared is equal to 25. I take the square root of both sides. Remember, taking the square root means that when I factor it, when I do my factor tree, I've got 2 of something. So this answer is going to be c equals 5, or h. Remember, c, I'm using the c for hypotenuse. So that's where the h come from. Alright, number 7, I said a is equal to 1, b is equal to 3, and find c. So I've got c squared is equal to 1 squared plus 3 squared. C squared is equal to 1 plus 9. C squared is equal to 10. I take the square root of both sides. C is equal to 10, the square root of 10. Because when I factor it, I get 2 and 5. I don't have 2 of anything, so I can't pull it out. So everything stays under, so it can multiply back out, so it's the square root of 10. And that's my C. I erased the C, oh no. Ah! Okay, now on to number 8. I tell you that A is 2 and B is 5. Find C. Again, I have c squared is equal to 2 squared plus 5 squared. C squared is equal to 4 plus 25. C squared is equal to 29. I take the square root of both sides. C is equal to the square root of 29. And there we go. Yay! Alright, continuing on. Number 9, I've got A is equal to 6 and B is equal to 6. Find C. So I have C squared is equal to 6 squared plus 6 squared. C squared is equal to 36 plus 36. C squared is equal to 72. I take the square root of both sides. I do my factor tree over here. 72 is 9 times 8. 9 is 3 and 3. 8 is 2 and 4. And then 4 breaks down again to 2 and 2. Now I have 2 3s and 2 2s, which means I can take one of each out. So I'm going to have 3 times 2 square root of 2, because I still have this 1 2 left here. So the answer is you see that? Yeah, okay. Square root of 2. So again, whenever I have a pair of something, I can take it out. Now I'm going to take this answer backwards for you just so you can see what's going on. So the answer for 9, C or H, is equal to 6 square root of 2. Now what this actually means is that if I put this back in there, I'd have to put 2 back in. So I'd actually have to go like this. 6 times 6 times 2. Now if I take 6 times 6, that's 36. Times 2 is equal to 72. And that's what we got before. That was the answer to our problem. So square root of 72. So see, this is what you're doing. And now even though it was a bunch of 3's and 2's, that's the same thing. If I wrote out, that's my honey. If I wrote out the square root of 3 times 3 times 2 times 2 times 2, I would still get the square root of 72. That would be my answer after multiplying that all out. So that's how we're doing the square roots. That's what it means when we're breaking it down. All right, so number 10. Oops. 10. A is equal to 2. B is equal to 3. Find C. C squared is equal to 2 squared plus 3 squared. C squared is equal to 4 plus 9. C squared is equal to 13. Take the square root of both sides. C is equal to the square root of 13. And that's the first 10.